Hello, ladies and gentlemen. My name is Mohammad Waleed, and I will be talking about my project Wave Energy Harvester. So, moving on to the introduction and inspiration for the project, the inspiration came from simply the fact that the climate is changing due to global warming, which is happening due to the burning of fossil fuels in order to generate electricity. Moving on, since ocean wave energy has estimate of 2 terawatts of clean energy generation just waiting to be harvested. Therefore, beginning with an example of an ocean wave energy harvester, as you can see on the left, to the right, you can see a typical linear generator wave energy harvester. We will be modeling this for our simulation part in the generation of voltage. The aim of this project is to simulate wave energy harvester model and to build a power circuit to charge a battery using the model. The objectives include to develop a wave energy harvester model in Simulink, to design a power circuit capable of charging a battery with steady voltage using the wave energy harvester model, to develop a machine learning model capable of predicting voltage generation from the energy harvester model. And lastly, we will be evaluating the performance of the developed system. Let us talk about the sustainable development of this project. Wave energy harvester we are looking into uses linear generator. Linear generators are usually made of magnets, coils, and current carrying wires. So they do not require any extra or special material which is not already being mass produced. Furthermore, there is little to no impact on the ocean and marine animals, meaning that the energy harvester has no side effects or harmful effects on the ocean or the marine animals. Furthermore, there is no byproduct produced and requires basic maintenance, meaning that only voltage is produced by the wave energy harvester and it does not produce any green emission gases. And the basic maintenance include changing the battery once every 2 years. And furthermore, this wave energy harvester can directly power rural or small villages near the ocean since it is capable of providing high voltages. Moving on to the novelty and innovativeness of the project, there will be three subsystems that are working together, which is not done before. And the system is so fully self-sustaining, meaning that it won't require any external voltage or device to start the wave energy harvester and the further processes. Industrial applications include that it can be used to provide power to the grid, or it can be used to provide power to sensors which can send data using transmitters for the ocean study purposes. These sensors can be placed on the wave energy harvester itself and without requiring any power, external power, since it can power them using the battery. And lastly, prediction model can predict irregular wave behavior by prediction when the voltage is like anomaly high, meaning that there will be some kind of irregular wave behavior. So we can use that as well. For the application, the battery selected is a typical 12 volt 5 amp hours, which costs about 40 ringgit, and the size is very small, so it can be installed on the harvester itself without taking a lot of precious space. Assuming that all sensors combined have a total current consumption of 300 milliamp, and using the formula given, we can estimate that the battery would last about 16 hours without requiring to charge. However, the wave energy harvester will be charging the battery as it works based on the wave. However, this is a precaution, meaning that even without, if something breaks down in the wave energy harvester, it will still provide about 17 hours, 16 hours of battery. Moving on to the development and outcome of the project, the simulation wave model was built using this formula. The voltage produced is directly linked to the amplitude of the wave height, the distance divided by 2, and hence the voltage is sent through a rectifier, which is to convert the which is to convert the AC voltage into DC voltage. Once it's been converted, a buck booster is used to ensure that the voltage stays within the limit of the charging voltage required of the battery without damaging it, since the voltage produced would be greatly higher than the required for the battery. Therefore, a fixed voltage is used as a feedback to provide to the MOSFET, which ensures that the voltage stays within 14 volts and the required voltage to charge is 12. So this is the actual results I found using a journal. So the displacement is set to 0.05, which is similar to identical to ours actually, distance divided by 2. And the output voltage is produced about 80 volts, and whereas in the simulation it's produced about 85 volts. So it is within the margin of error. Moving on to the prediction part of the simulation, we can see that I collected the data from Townsville wave height data of 2017. It shows the maximum height of the wave reached during a certain set of time. So using that formula max in the Excel, I found that the maximum height reached was 3.9 meters. So this is the upper limit set for the data generation. Data was generated using LabVIEW and saved in an Excel file as shown. Once the data was generated in thousands, it was ready to be used for training our model. The model used is polynomial regression, since using any other model like CNN or ANN, which is mostly used for classification, yield low results. Therefore, I decided to stick with polynomial regression. And the prediction versus the actual, which is shown in the blue is the actual and in red is the predicted, is within negligible error. So that is all. Thank you and have a nice day.